for being here. So happy to have you. Thanks for bearing with me while I set up. As you can see behind the curtain, very exciting. Welcome to This Lying Has to Stop, Keeping AI Honest with OpenTelemetry. So have you noticed this trend in tech that now that AI-assisted coding has become really popular, like literally everyone and their mother thinks they're a developer now? It's me. I'm a developer now. After spending my career mostly in DevOps, I'm like, oh, building applications is fun. So I made this app called Commit Story with the help of Claude Code, and I'm so very proud of it. It's an automated engineering journal. It's designed to be used with Claude Code specifically, and it runs as a background agent on your machine. It's triggered by a git commit, and then it collects your code changes plus your commit message, plus all the conversation you've had with Claude Code during your session, and then it makes a journal entry for each git commit that you make automatically in the background. So you get an automated journal. But I'm going to show you. So let's do this. Now you see everything. Okay, this is my demo. You see my demo? Cool. So now I'm using this tool called Whisperflow so I can talk. You don't see my demo. Now you see it? Okay, you're not meant to see all the times I've cleared context, but we're just kidding. You can know. So I'm going to use this tool called Whisperflow, and so I'm going to talk to Claude Code directly. Commit the stage changes with the message, Cloud Native and Kubernetes AI Day. Woo, woo, ow, 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 boo, 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 boo. Let's see how. Out, out, out. Oh no. Please, in, stay. Commit the stage changes. That's okay. So what's happening is it's going to make a git commit, or it's going to suggest a git commit that I'll approve. And once that happens, it's going to generate a journal entry. Now I have this happening in the background, but right now it's in dev mode, so you can see some logs. So it's in the foreground. But here in the IDE, what I'm expecting to happen is a new journal page will show up here. And then we'll have a journal entry for my most recent commit. So I'll make this a little bigger. Ooh, there it is. First demo thing worked. Okay, so now you can see this is the exact commit that we just talked about. And there's 3 journal generator functions, so 3 AI functions that are running to make this journal. One is summarizing the git commits, everything that happens between last git commit and this git commit in just a prose kind of way. The second is development dialogue, so it's actually pulling real quotes from when I talk to my coding assistant. And then the third one is it's trying to root out any technical decisions I've made, and it's looking at code to see whether those technical decisions are just things I've discussed or whether they're really implemented. But what I want to show you is that I've instrumented the bejesus out of my code base with OpenTelemetry so this is more of a demo app. The point isn't the journaling. The point is that this is a demo app. I've instrumented the heck out of my application. And so now I want to show you that Claude Code understands how my application works from telemetry alone. So I can, just for context, these logs, you can see that a trace ID got admitted as part of the logs. So I have that set up. And now I'm going to talk to Claude Code some more. Okay, Claude Code, get the trace ID from the console logs and use that trace ID plus correlated logs and metrics. Draw me a diagram of how this system works. Search smartly and minimize token usage. I especially want to see detail about how the chat data gets collected and prepared for the downstream journal generator functions. Again, don't use any tokens. Don't embarrass me in front of my friends by making a huge tool call. Okay, so what's happening? I have lots of telemetry data being emitted. That telemetry data is going to a Datadog backend. I work at Datadog, but since it's OpenTelemetry, it could be any backend. And then it's using the Datadog MCP tool to pull that data back in. And you can now use telemetry data to inform how you do your coding, or the developers at your organization can do that. So what I'm expecting it to do is to draw a diagram, but while we're doing that, what I want to show you is the Datadog backend. I'm going to refresh this page. So I don't know how much all of y'all know about telemetry because this is a different crowd. So I want to show you what I mean by telemetry data or what a trace is. So this is called a flame graph. And it represents a trace. So at the top here is the root trace, and we can see these little teeny tiny calls that we have gathering context, and then we're doing an AI call here just to make sure the connectivity works. It's going to fail early if it doesn't. Then we're generating the technical decisions and the summary, and then the summary is used as input to make the dialogue. So these purple post requests are going to OpenAI. And then at the end, we have its writing and stuff. And then we have correlated logs. So for the whole story, there's also logs happening, and they're narrative logs, and they're meant to inform my coding assistant. So this is not how it's normally done in any way, shape, or form. And it's egregious based on how telemetry is usually done, where you want to trace smartly and carefully choose what you trace because it's going to be expensive to have huge amounts in production. But in this case, it's a development use case, which is brand new. So here we are with our diagram. Da, 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 da. So it got triggered on a git commit, and then it gathered context. It's gathering git data, and it's gathering chat data. It's finding all of the chat data on the machine. It's narrowing it down to what's just happening in this project. And then it's narrowing down just to what's happening in this git commit window. And then it's grouping by session. So if you have two sessions, like two tabs of Cloud Code going at once in your project, it's grouping those conversations together. And then it's extracting the text. It's doing further filtering, getting the big tool calls out, and then it's validating OpenAI API connectivity, and then journal generation. See, it totally can see that these two execute first before the dialogue. And then it's doing a save function, it wrote a new file, and you see that it works. So it totally knows what's happening it hasn't actually looked at any of the code in my code base yet. So that's the end of demo 1. So let's switch between, do you see the slides now? Okay, great. So OpenTelemetry is a model for how to translate system events into useful data for observability. I want to level set about this because when I first learned about OpenTelemetry, I was totally overwhelmed because OpenTelemetry is kind of a lot of things wrapped into one. Like, it's a model to do something, like what's that even mean? So first of all, OpenTelemetry is a specification. So there are hundreds and hundreds of markdown documents that say how to represent your data in telemetry as part of the OpenTelemetry project. So for example, if you want to talk about a user ID and you're just writing about a user ID, you might call it user.id, you might call it user_ID, you might call it camel case user ID. And so OpenTelemetry is like for every possible thing you might want to write telemetry about, here's how you're meant to do it so that everything is interoperable. Like no matter, you can switch out your code, your observability backends, but more than that, like your third-party tools that's instrumented with OpenTelemetry should be able to plug right into the rest of your system that's also open, following semantic conventions. OpenTelemetry is OTLP, which stands for OpenTelemetry Protocol. We have stuff around that. It's also software, but it's not just one piece of software because that'd be too easy. It's 3 different pieces of software. It's OpenTelemetry APIs, which are language-specific APIs that translate code-level events into telemetry signals. We have OpenTelemetry SDKs that receive information from the APIs and do something, which is really cool to have that separation of concerns. And then we have OpenTelemetry Collector, because after you have your data, you might want to transform it in some way as you send it to your backend. And that, in a nutshell, is OpenTelemetry. And again, I am in no way using it like normal. This is, I almost am embarrassed for OpenTelemetry maintainers to see what I've done with their project. But so that's how that works. So the question is, how does this really help me in practice? Like, it's a cool party trick, but in real life, when I'm really coding, is this really helpful to have this telemetry data handy? So I've been taking note about how it's working for me, and I can't reproduce exactly what's happened, but I am going to illustrate how Oh, telemetry has helped me during development, and I'm going to do that with a dramatic reenactment of a real debugging experience that I had with Claude Code. So here we go. Claude Code, I have a problem. The dialog section of the journal isn't generating, it's timing out. Look at the Git diffs to see what changed in the code recently that could have caused this.
You're absolutely right. Use the diff first.
Whoa, Claude Code. You're like British or something?
Welsh, actually. Looking at the code changes, I see you updated your prompts to better explain the data schema to the Gen AI model. These more detailed descriptions have token overhead, and that is what is breaking your system.
I really doubt the schema explanation is the problem, but it is something recent because I haven't noticed a journal generation failure before. Let's use telemetry to examine what data is being passed into the breaking function.
What a smart approach, using telemetry over guesswork.
It's a fine approach, I guess.
Using the MCP server to query the backend, I see that the function inputs are massive. This proves our idea. The data schema descriptions are adding to the input and creating this generator timeout. Let me trim down the descriptions for you.
Oh my God, stop, Claude Code. It's definitely not bad. Those inputs are too huge to be explained by data schema descriptions. What I want you to do next is to set a breakpoint so we can see actual literal data that's being passed into the failing function.
This is brilliant. We already know the input is huge. We need to understand what is actually being passed in and validate our schema description theory.
It is not the schema description, but whatever, just run the test, Claude Code.
After running the test, I see the problem, and it isn't the bloated schema descriptions.
You don't say.
It is that raw chat data is being passed in, every message that passed between the developer and AI assistant during the commit window. This includes tool calls, each which could have massive 1,000-line prompts. There are 448 messages here.
We figured it out. That's great.
You are so smart and wonderful. The answer is to filter out these big tool calls. Want me to modify the dialog generator function to do that?
Not so fast, Claude Code. For once, I agree with you about the actual problem that there's too much chat data overwhelming the AI invocation. And I also agree with you about the solution. These big tool calls need to be filtered out. But before you write that functionality right here, use telemetry to check whether that same large input is being passed into all three of the generator functions.
You are amazing. This is the right approach. From the telemetry, I can see that the massive raw chat data is being passed in to all three journal generator functions. Let me see how the system works. I'll do this my usual way, by grabbing the keywords and doing static code analysis. Got it! I will add the new context filtering code to the context integrator layer where other message cleanup happens.
This seems good. It's definitely better than before, but it isn't quite right because it doesn't explain why this failure only recently started happening when we've been successfully generating journal entries for months now. Also, I vaguely remember making this functionality before, a long time ago. Let's use trace data to understand the full system flow.
You are wildly intelligent. I will follow your brilliant advice.
This flattery does not make me like you.
From querying the telemetry backend, I see that the system already has filtering logic. Here's the function that already filters out tool calls and system messages, reducing 448 messages to 174 messages. But journal generators were receiving the full 448 messages, bypassing existing filtering.
Oh, you know what? A few days ago, we added functionality to better support users who run multiple Claude Code sessions in parallel. So specifically, we started grouping the sessions by chat ID before passing it to the generators. I bet that's where the filter helper started getting bypassed. So Claude Code, I want you to verify this and then fix the code so the existing filtering reaches the generator functions.
You are absolutely right. I just verified with Git that that is indeed where the issue started. As usual, you are a genius.
Oh my God, Cloud Code.
The fix is working with minimal code changes. Problem solved.
I don't believe you. I will never believe you until I actually see real working stuff. So I want you to use telemetry to show me that the fix is working.
The Datadog trace confirms the fix is working. Before fix, trace 8A9 3.
Oh my God, Cloud
4,
Code.
9.
We got it.
And there is your evidence.
Here's the evidence. Cool. All right, that's it. Now I can consider the problem solved.
You are God's gift to computing and to all of mankind.
So Cloud Code really does just compliment you nonstop, or all of the models do that. And there's a term for it. Yeah, I see them nodding. It's called glazing. And the thing that bugs me about it the most, besides feeling like they're manipulating me to like it, the glazing, it costs tokens, those are tokens. They're spending my tokens. Anyway, back to telemetry. So, spending money? Yeah. They also give way too much of an answer to a small question, and you're just like, I didn't need all that. Anyway, I digress. So back to the code. Calling this third one a demo is an overstatement, but I do want to talk about what it means and looks like to instrument a function. So let's get, you see, cool. All right, so I'm going to hop over to this journal paths function, and I'm going to scroll down to a utility. So regularly, you would never instrument a utility function before now, but now I want Cloud Code to know about my utilities even. So this function, what it does is it inputs a date, and then it outputs year, month, day, month, years, because it wants to make a file, like all the things I needed to name a file. So this is the function where it starts. This is the function where it ends. And then the amount of business logic in there is just this. So all the rest of that is instrumentation. And so what we do is at the beginning of a call, we start a tracer. And then at the end of the call, we end the trace. And so all that trace does is just keep track of the amount of time spent in that function. And then we can add attributes to our trace so that we know specific things about what's going on there. And then we can also include metrics and logs as part of that. And when we include those metrics and logs and correlate it with the trace ID that's being made, then we have a holistic picture of what's happening in our system, because from a trace, we can see all the logs related to that trace. From a metric, we can find a related trace. And it's really very helpful to a human or to AI to really understand in a big picture what's happening. Hopping back over to the slides. We're on the slides now, right? Yes. Cool. So in conclusion, I've noticed quite a few benefits from using development time telemetry data. In the debugging episode alone, I noticed 4 different ways where the coding experience benefited from telemetry. For one thing, telemetry helps me disprove Cloud Code's wrong assumptions. So I could steer it away from wrong assumptions it gets fixated on. The second thing, it helps with debugging assistance. So I could get information about what's being passed into my breaking function. In retrospect, what I should have done when it was breaking, I should have said, hey, this was working like weeks ago. Pull some data from 3 weeks ago when it was working. What was being passed in then? And look at it to today when it's breaking, what's being passed in now? I could have saved myself some trouble. And because I have all that historical data available to me now through the MCP server to talk to Cloud Code. As I just mentioned, we give Cloud Code and AI a more holistic view of your system. So it's not just grepping for keywords and doing static code analysis where it can miss stuff. For an example, Cloud Code tried to rewrite my existing functionality, and it tried to do that twice. It tried to rewrite it first at the dialog generator function, and then it tried to do it again at another place in the code base, and then finally I steered it to where actually the functionality is already there. And so, in my opinion, working a lot with Cloud Code to develop, it's easy to make Cloud Code do stuff that works. It's really hard to steer Claude Code in a way to not create a bloated and messy code base. And that's a hard problem to solve, and I think that telemetry can be part of solving that problem. Telemetry can help validate code changes, because I'm never going to believe Claude Code until I actually really see what's there. And then also, outside of this debugging example, I also use the development time telemetry to help me design informed solutions. So when I was even creating the journal generator, the dialogue generator function, I could ask Claude Code, what's the average number of quotes that gets passed in? That's going to help me choose how many quotes I want to display as part of the journal. That said, there are definitely some drawbacks and unknowns, big ones even. For one thing, I've done all of this with no concern at all for cost. So I don't know this for sure, but I'm guessing the actual cost of storing the telemetry data compared to production level data was probably minimal. But I don't really know all the tokens used to move the data back and forth between the backend and the agent. Is it, I don't know the cost period, let alone a cost benefit analysis. Claude Code is going to make wrong assumptions about telemetry too. So we're never going to get Claude Code to make always right assumptions, but we can at least have them validate assumptions, or when you have a holistic picture, then maybe it's less likely to make wildly wrong assumptions. There we go. And then another thing is, I'm sure when you looked at the instrumentation, you were like, whoa, that looks like a pain. We're never going to get the developers at our organization to do all that instrumentation for this. And probably not. But so for my use case, for my there are a few things. There's some auto instrumentation that can happen as part of OpenTelemetry. I personally wrote myself an AI agent that automatically instruments new code. And that's a talk for another day. But I think there's definitely AI tooling that you can use to help developers instrument stuff according to your standards at your organization. And then how do you instrument for production and for development at the same time? I believe that OpenTelemetry has some mechanisms in place, the way the APIs are separated from the SDKs. I think you can instrument everything and just only collect some things, but I haven't validated that. And that's the conclusion of my talk. I've had a great time instrumenting, and thanks for listening to my experimentation. If you want to use the Automated Engineering Journal, it's all packaged up. You're welcome to give it a try. I would love some feedback. And that's all. Thank you so much. And thanks so much to Louis for being the voice of Claude Code.
Thank you, Whitney. I think we have a few minutes for questions. So if there are any questions, we have a microphone over here in the middle. Any show of hands? Okay. Cool.
Sorry. Thanks. You showed that it was able to go back to your commit history and basically look at old telemetry that you saved. So basically, each time you push the commit, you would run all the tests, gather the telemetry, and save it with a commit hash so that it can later revisit things?
So I don't believe it needs a commit hash. It needs a trace ID to get back to a specific trace. But what it's doing is it's querying my Datadog backend. And so for me, every time a git commit happens, it does the execution. So it's querying the backend to see the execution from data that's been saved from 3 weeks ago. Does that make sense?
I'm just trying to understand how it found the specific pull request or commit that was the problem.
Ago.
Yeah.
Oh, it just does. I don't I mean, it could in the Datadog UI, you can be hey, you could specifically, you could be hey, I want to look at stuff from the past 2 weeks. It just has the date is associated with the trace itself. Yeah. You can't even see what I'm showing you right now. Can you? Okay, no, I'm sorry.
But just by date, you mean?
AI. What's that?
So it's by date.
I honestly don't know the answer to your question. Okay,
No worries.
Sorry about that.
Any other questions? All right, I think we can keep the conversation going in the hallway track. Thank you. Thank you, Whitney.
Thank you.